Right, good afternoon, everyone. Welcome to this session on Cobalt 100. My name is Bhumik Patel. I'm with ARM. I'm really excited to bring this session to you, and we have a great set of speakers from Microsoft and Databricks to talk about how you can get better price performance by deploying your applications on Cobalt 100. Let's get started. So we have a packed agenda. I'm going to give you a quick update on what we are seeing in terms of developers building their applications on ARM, and then quickly get into Cobalt 100 related updates. Right? We'll talk about how you can leverage the VMs in Azure, and then hear from Databricks on how they are benefiting on deploying Databricks on Cobalt 100 from a price performance perspective. Then we'll have Roger talk about how MDE, you heard Satya mention on the stage that Microsoft Defender for Endpoint is migrating to Cobalt. We'll hear about that. Then we have Brian, who will do a demo on AKS and show you how you can build your cloud-native applications, and then we'll wrap up on what this means to you if you're getting started, how can you leverage some of the resources we have. Right? So a little bit about ARM. Chances are, every one of us interface with ARM-based compute in our daily lives, right? Whether we know it or not, whether it's the consumer devices or commercial apps that are running on ARM-based compute. ARM as an architecture is ubiquitous across the spectrum of segments that we cover, right? So over the years, what we've seen is increasing amount of developers building their applications on ARM across IoT, embed, client, and then today's focus obviously is cloud applications, right? So we have this massive ecosystem of software developers. You can see some of the stats on number of chips being shipped, and it's kind of exponentially growing. We kind of are the most ubiquitous architecture. You probably know us for being power efficient, but with bringing CPUs in the cloud, we're also being performant, right? So why are developers building on ARM, and why should you build your cloud apps on ARM, right? So it all starts with our investments in the platform level, right? So we have ARM Neoverse-based cores, which are highly scalable and performant, which is what Cobalt 100 is based on, right? So that kind of gives you the platform where you can get the performance at scale and at also energy efficiency in the cloud and the cost benefits. We've been in this space for a few years, and we've been investing heavily in the software ecosystem in terms of bringing all the applications to you, right, across the layer. So whether it's the Linux distributions that kind of work out of the box, or your container and build tool chains, right, whether it's Kubernetes or any of the other cloud-native projects, you can just build your applications natively on ARM 64 without any issues, right? And then we also invest in optimizing the frameworks across the stack, whether it's .NET, Java, or even ML frameworks, and really get you the performance that you need to run applications at scale, right? So, and we kind of showcase, the 1,000+ listings of software, whether it's open source or commercial apps that you can. We have a dashboard. If you go to ARM software ecosystem dashboard, you could see all the software that's supported on ARM, so you can get quickly started. And then one of the main driver obviously is TCO, right? You get better performance and price. And then increasingly we are seeing those trends for AI and ML apps as well, whether it's your inferencing use case or running your SLMs, doing natural language processing. We have demos at the booth that shows like 5.4 with Onyx framework running inference use cases on Cobalt 100, right? So across the application stack, you get better and better performance, right? So these are some of the key reasons why developers are building on ARM, and you should also consider kind of leveraging Cobalt 100. And the way we bring this to you is through a strong partnership with Microsoft, right? And it kind of spans across those layers that I talked about, right? Whether it's silicon innovation, bringing Cobalt 100 to you, right, based on the ARM Neoverse architecture, kind of innovating, a lot of innovation going at the silicon level between our engineering teams that kind of brings you Cobalt 100. But we don't stop there, right? We continue to invest in the software engagements across the software properties with Microsoft, right? So for example, GitHub runners support natively the ARM architecture for both Linux and Windows based, so you can just build using GitHub on ARM. .NET gives you saw in the keynote, 2x performance on Cobalt 100. So there's a lot of optimization work we are doing, work closely with the Microsoft engineering teams across the stack, right? Bring you tools like Windows Perf and others. So kind of make sure you have the robust set of tools when you're building your apps. And then last but not least, also kind of extend that leadership into the ecosystem. So you'll hear from Databricks today, and then kind of make sure all our ecosystem partners are enabling their software solutions for Cobalt 100, so you can, it's ready for you to deploy. So with that, I'll transition over to Amar, who can walk you through the Cobalt 100 VM offerings in Azure.
Thank you, Bhumik. Good afternoon, everybody. My name is Amar Dhamdhere, and I work for Microsoft, and I'm a part of the ARM VM sizes team, where we are a small team working on defining the ARM VMs and bringing those to Azure users and our customers. The folks who are going to come and present after me are going to have way more interesting things to say than what I am going to, because these VMs, we launched them in October of 2024, and I believe most of you are probably familiar with Cobalt 100 virtual machines. So I'll pick up the pace over here so that I can transition it over to the other folks. If I can bring your attention to the right-hand side of the screen over here, Cobalt 100 VMs are bringing you double-digit performance and price performance benefits over the previous generation VMs that we introduced, which were based on the Ampere Ultra processor. When it comes to CPU performance, you'll see 40% better CPU performance. For Java-based workloads that are popular on ARM architecture, there you'll see 50% better performance. When it comes to web servers, .NET applications, and other workloads, you'll see 2x performance benefits. And because these VMs have NVMe local storage disks, you get 4x the local storage IOPS. And of course, this is ARM architecture, so with that comes power efficiency. And so the Cobalt 100 based VMs are the most power efficient VMs right now in Azure. These are available in 22 regions as of today. Our footprint is going to continue to grow. But in those 22 regions, you'll also find regions where we have zonal, 3 zones as well as 2 zones available for our customers. Some of the key customers over here that are on Cobalt today and deploying their workloads are Databricks, and you'll hear from Zach later on. We also have Snowflake, Elastic, Amadeus, and we have a number of other customers that we'll talk about later as well. We've launched, or we're offering 3 different VM families. These are the D series, DP series, DPL, and the EP series. If you see a P in a name, P as in pen, if you see that those are the ARM virtual machines. So DPL, DP, and EP, all of these have 2 to 96 vCPU VM sizes. The key difference between these 3 is on the amount of memory per vCPU that you get. The DPL comes with 2 gigabytes per vCPU. The DP comes with 4 gigabytes per vCPU, and the EP comes with up to 8 gigabytes of memory per vCPU. All of them have a diskless as well as a disk full option. Disk full is the ones that have local storage attached. You have up to 5 TB bytes of local storage available. From a network bandwidth, the largest VM size will give you 60 gigabits per second, and remote storage you have 40 gigabits per second. Across these 3, you can support a wide variety of general purpose workloads, all the way from media encoding to data analytics workloads. And they also have an option for remote storage. Okay. We wanted to integrate these VMs into the Azure experience that you're already familiar with on x86, right? So when you want to deploy or want to use the Cobalt 100 VMs, you will deploy them similar to how you've deployed them on x86. So these VMs are accessible to you through the Azure Resource Manager, which internally we also call as ARM. So sometimes we run into that confusion there. But Azure Resource Manager, you can use that. You can use Portal. You can use CLI, PowerShell, SDKs. For the different types of operating systems or images that you want or extensions that you want, the Azure Marketplace has all of those similar to x86. We also support a wide variety of capabilities like virtual machine scale sets or VMSS is supported, Spot VMs, Spot Mix is also supported. VM resizing within the same VM generation is also supported. Then we also have Azure Monitor and Azure Backup and other features that are available. And of course, AKS and Databricks, right? AKS is one of the most used architecture or technology that or service on the Cobalt 100 VMs. With that, let's talk about the momentum. We are seeing significant momentum with Cobalt 100 VMs. This is driven because of two primary reasons. The first one being the migration journey is easier. I won't say it is, depending on the workload. There are many workloads that can move over to ARM with minimal effort. And so that makes the Cobalt 100 VMs attractive to customers. And the second and one of the key reasons is the performance and the price performance benefits that Cobalt 100 VMs offer over other architectures. So you can see customers over here like Rescale, Elastic, Templify, all of them are experiencing performance improvements for their workloads. And Templify over here says they see approximately 25% higher throughput at 35% lower CPU usage. So and this is all compared to the Ampere Ultra-based VMs that we also have today. So that's significant performance benefit that customers are seeing with the Cobalt 100 VMs. And I'm not going to name each of these customers over here, but yes, we are naming a few of the customers who are deploying on Cobalt, but the momentum is growing, and we expect that to continue for quite some time on Cobalt 100. With that, I'll hand it over to Zach to talk to you about Databricks and how Databricks is deploying their solutions on Cobalt 100. There you go.
All right, this fell off. All right, thank you. I'm really excited to have the opportunity to talk today about how we're getting price performance benefits at Databricks using Cobalt 100. My name is Zach Christofferson. I'm a performance engineer at Databricks, and as part of performance engineering, I'm responsible for the evaluation and onboarding of all compute, regardless of cloud, to the Databricks product and Databricks platform. And that looks like two different things. So we have a category of products that we consider like classic compute. In these products, customers are able to specifically choose which compute instance they want to run on. And then we have another group of products that are called our serverless compute offerings. For serverless compute, Databricks is making the decisions about which compute to use, and then we're able to optimize what's used behind the scenes to deliver the most value and performance to our customers. And I've been personally involved with the entire evaluation of the Cobalt 100 offering, as well as the previous generation ARM offering on Azure. And to be honest, I couldn't be more pleased with what I've seen from Cobalt 100. So real quick, Databricks' mission has always been to help data teams accomplish, our mission has always been to help data teams with achieving any sort of data or AI challenge to solve some of the world's toughest problems. And what that means in practice is we're seeing something like tens of millions of VMs being provisioned every single day in order to accomplish this. So when we're talking about a scale such as that, it's critical that we're able to deliver scalable, robust, and cost-effective compute. And that's where the Cobalt 100 compute really comes into play. The performance speedups that we're seeing from these, both performance and efficiency, are extremely significant and critical in keeping your performance high with your operating costs low. And in our own internal evaluation, we've evaluated that on Azure Databricks using Photon, which is our native vectorized engine, we're able to take full advantage of both of the performance and efficiency gains of the Cobalt 100 VMs. So to talk a little bit about how we approach onboarding instances and what performance looks like, there's really 4 key dimensions we like to focus on. The 2 at the top, performance and value, these are pretty obvious ones, right? Like the standard was set long ago. As new generations of compute come out, we're expecting improved performance and improved value. But I'll talk a little bit more about simplicity and consistency because we'll be circling back to some of the specifics around what we've measured with performance. So another dimension that I value very highly when choosing new compute to onboard to the platform is simplicity, which means how easy is it or how frictionless is it for a customer to make a migration to this compute type or adopt this new compute type without needing to do any sort of specific tailored customizations for it, massive changes to their build process. How simple is it for them to realize the full potential of the compute? And then with regards to consistency, what we really like to see is universal performance improvements. So we have many, many customers running all sorts of diverse workloads. So it's extremely valuable if we can point to a particular compute offering and say, without even knowing the nuance of the individual workload, we can have a lot of confidence that they're going to realize significant performance improvements by making a change to Cobalt 100. And regardless of what cloud I'm evaluating compute for, it is extremely uncommon to see a new compute offering that meets or exceeds the bar in all 4 of these key dimensions, but that's exactly what we're seeing with Cobalt 100 on Azure Databricks, which is just fantastic. And when we see those 4 dimensions being satisfied, we get extremely excited. We get excited for our customers because if they're using classic compute, that's just value on the table. You can make a migration to this new compute, start realizing those benefits immediately. But we also get excited for ourselves because it allows us to now implement this compute within our serverless platform and then give that benefit to all customers automatically without them even needing to be aware of it or having to make any sort of modification or changes on their side at all. And now, to stay on the topic of like universal benefits and performance gains that are universally applied, I want to take a quick aside to talk a little bit about something that's not necessarily Cobalt 100 specific, but it does come coupled with the new instance family. And that's an increase in maximum networking bandwidth. So the most common cluster worker shapes at Databricks are in between 8 and 48 nodes. And compared to the prior generation ARM compute on Azure, we're seeing 20 to 25% increases in max networking bandwidth. So this is super critical for any of your payloads within a data lake or lakehouse architecture. These are often experiencing a network bottleneck due to large amounts of reads or writes from cloud storage. So by adopting Cobalt 100 for a workload such as that, you see an immediate acceleration, if that was your bottleneck, and you see better leveraged and utilized compute throughout the cluster now that you've alleviated some of that bottleneck. So if you have a collection of workloads and you're trying to decide like which to prioritize a migration to Cobalt 100 first, these types of payloads are specifically benefiting from very significant performance gains. And then to talk a bit now about how we approach overall performance testing and evaluation, there's really like 2 classes of performance tests we look at. There's the industry standard benchmarks. You may have heard of these like TPCDS, TPCH. There's some pros and cons to these. I'll talk about why we value them, and then I'll talk about how we address some of the downsides to them in the next part. But TPCDS and TPCH we find are very valuable for a couple of reasons. One of the reasons is that it's an actual like end-to-end benchmark which exercises the entire Azure Databricks and Databricks runtime system with Photon. So by doing that, we're able to actually quantify any overheads that may be inherent within the system, and then the output that we get from this type of performance evaluation is very similar to what a customer with a similar workload should expect to see. So this is very different from what you would expect to see if there was, say, like a OS micro benchmark, right? There's no guarantee that we're going to actually realize that performance within a Databricks runtime payload. But with this, we're able to say, hey, we can measure this performance uplift for real Spark workloads running on Databricks, and we would expect customers to achieve the same. Now, there's a big downside to these types of TPCDS, TPCH standardized benchmarks in that they're not super reflective of all customer workloads, right? These are read-only workloads. A huge chunk of Databricks usage is massive data transformations and writes to cloud storage, right? So what do? Over the years, we've curated a comprehensive collection of what we call performance primitives, which are essentially optimized and simplified test cases that stress one particular aspect of the system. So we have like a collection of these for writing to cloud storage, reading from cloud storage, data exchange node to node in a multi-node cluster environment, sorting, things such as this. So what's it mean for Cobalt 100 though? It doesn't really matter like what we are, which one of these benchmarks we're looking at. The gains are so universal, right? This is all like median latency reduction. And we're seeing anything from like 25 to 35% here. If you look at the actual distribution of these performance primitives, we have plenty of common patterns and primitive patterns that are getting beyond 40% improvement on Cobalt 100. So overall, like Cobalt 100 is a huge win. It's a win for customers, it's a win for Azure, it's a win for Databricks. We're so impressed with this compute that we're actually going all in on it with serverless SQL. We're making it the primary compute and preferred compute for our serverless SQL platform. So if you're currently a serverless SQL customer, you'll get that benefit in the near term as we roll that out to our global fleet. And that's without any action or reconfiguration on your side. If you are a classic compute customer, these instances have been out and supported in Databricks for some time now. You can use them immediately. I'd recommend using them with Photon in the latest LTS Databricks runtime release. And all in all, we're super happy to have this collaboration with Microsoft Engineering. And I think that this collaboration ongoing into the future, we're excited to continue to be able to deliver the best infrastructure to our shared customers to allow them to satisfy any sort of data or AI initiatives that they take on. Thank you.
Hey there, all right, folks. So my name is Richard, and I'm a principal software engineering manager and architect for Microsoft Defender for Endpoint. And over the next few minutes, I'm going to share our journey for modernization and some actionable best practices that you can use to move from x64 to ARM. Okay, so first, let's talk a little bit about what Defender for Endpoint is. So Defender is a software suite it's a comprehensive software suite that's running on billions of devices and processing over 80 trillion signals every single day. It runs on everything from your phone and your tablet to IoT devices on the edge, clocks, coffee machines, cameras, network switches, and kind of everything in between. It's part of a broader set of Defender for products. So Defender for Office, Defender for Identity, Defender for Cloud Applications. There's some booths out in the security area if you want to learn more about those products. And it's made up of hundreds and hundreds of services that are distributed in over 27 data centers in the world. And on a product portfolio that's been built organically inside of Microsoft and acquired over about 20 years. So if there's a version of .NET that's available, we pretty much got something running on it from .NET 1.1 all the way up to .NET 9. And so with that, there's a broad set of opportunities and challenges to modernize. Defender for Endpoint is taking this as an opportunity to consolidate. So we've been on a journey to transition over into using Azure Linux, and we run on Azure Kubernetes, and we're standardizing on .NET 8 in preparation to move to .NET 10 later this year. And we're adding into our mix of hardware Microsoft's Cobalt silicon to improve our opportunity even further. Okay, so before we get into your best practices, let's talk a little bit about what to optimize for. So it really helps to think about your application and what's important for your business and your workload. So there's some cost metrics that I have here on the slide of some ideas that might be important to you. Usually there's a trade-off there. So you have requests per second or throughput, you have latency, and it's really easy to hug either axis of that graph. but the reality is usually somewhere in the mix for there. For Defender for Endpoint, we are really concerned about the cost per request. So supporting those billions of devices out in the world, sending us tons of data every single day, we need to make it cheap and we need to make it fast. And so we're really focused on that cost per endpoint and cost per request. And so we want to try to slice it down as thin as we can to try to get the most scale to run the highest levels of protection for our customers. And so with that, that allows us on Cobalt, with the efficiency gains, to run more protections, to run higher fidelity protections like AI inference. And it also allows us to keep our latencies low so we can give fast response times to critical actions inside of the operating system. Okay, so on the technology, and now we know that what we're optimizing for, we can kind of frame our choices. So in Defender for Endpoint, we are optimizing for that cost per endpoint and latency. And for that, we kind of have three big levers that we can use. So one is hardware, one is platform, and the other is application runtime. So for hardware, we're currently running on contemporary silicon from AMD and Intel. And while each generation gives some improvements, with Intel and AMD, they have their own unique strengths. And each silicon generation makes improvements in throughput and things like that. But for us internally, that translates into costs. And I'm very sensitive about those costs. And so I want to make sure that I'm providing the most value for my customer while reducing the overhead. And Cobalt is a path for that for me. So in Cobalt's case, I get both higher throughput and lower power, and therefore, to me, lower cost, which means that I can use less and I can achieve the same level of service, or in the existing footprint, I can add more capabilities and provide more value to my customers. The second one we have to think about is platform. So we use Azure Kubernetes and Azure Linux. This makes it simple for us to think about everything in an entire stack. I care a lot about latency and sensitivity. Azure Linux has smaller container footprint. I can pull those faster, I can deploy those faster, I can boot them faster. The last thing is about runtime. So majority of our services, we did a modernization effort a handful of years ago to move to .NET 6. We're trying to move now forward to .NET 8 and then again in .NET 10. And each generation of .NET has fantastic performance improvements. Stephen Tobe every year generates his blog posts that I look forward to reading. And the improvements I'm anxiously awaiting in the next couple months, his .NET 10 improvement there. So each generation of .NET has higher and higher fidelity support for ARM intrinsics, better improvements in the JIT, memory management, and so you can take advantage of those as well. Okay, so now that we kind of know what's important, what are the levers that you can use, it's time to look at how do we operationalize that. So one of the most helpful things you can do is know exactly how your system currently performs against the metrics that matter for your business. And for this, you need to pick meaningful metrics that tie directly to a business outcome or user impact. And you need to observe the system where it gets the most, where you can get the most amount of physics you're sitting on top of. So for observability, so you can use application insights, for example, measure at the application level. What does your incoming rate look like? What's your latency going out to other services, other infrastructure? And you can export those and compare across the hardware platforms as you move that. And once you know where the system is, and you can measure things, then you need to make it repeatable. So moving over to ARM isn't like a one-shot deal. So for Defender for Endpoint, we've spent the last 6 months or so getting all of our services over, measuring, deploying, tweaking, tuning to get the most out of the hardware and the software. So there's obvious experiments of like for like. I took this as a D32AS v5, and now I got a D32PS v5, and I can do that, or PSv6 for Cobalt. But there's a lot of hidden things that exist inside of the ecosystem. So understanding your application, your workload, what it does, that's going to be really, really important to you. So the last thing that I'll give you that you can do to start right now is validation. You need automation. So not only do you need realistic performance tests and benchmarks, but you need to be able to validate functionally what's going on there. You're going to be turning this crank often, and so you want to make that as easy and frictionless as possible. Oh, that's not it. Okay, sorry, one more thing. So one of the ways that we've been working on this inside of Defender for Endpoint is to make the application experience and building those images much easier and simpler. And so in the past, what we would do is we'd generate a container image, and then we'd use some open source software to like generate another image and then stitch them together and then deploy those to Kubernetes so that we can run on any compute. Well, in partnership with the .NET team, we extended the capabilities inside of .NET 8 SDK to allow you to do container publishing for multiple operating systems and hardware interfaces in one gesture. So you can specify a property, and you can specify the runtime identifiers you want to use. So in our case, Linux, and we can specify x64 and ARM, and then I just call .NET Publish. And it's going to magically create a container for me that is exactly the format I need, that's open source, like an OSI standard. And I can deploy that right into my container registry and deploy that right out into the fleet. It's fantastic. It's super fast. It allows me to generate a container image locally. I can run that in Kind or Minikube, and I can deploy that to my infrastructure seamlessly. So it gets me set up today, even if I'm not using ARM for a service, so that when I do deploy those node pools on my Kubernetes clusters, they're ready to go, and they can just be scheduled. So it's super frictionless, super easy. App Insights also gives you additional visibility there. So that's it. Okay. Now I'll hand it over to Brian, who's going to give you a demo over some of the great things in Kubernetes.
Hey, folks. So yeah, I'm going to switch over to my demo screen. There we go. My name is Brian Benz. I'm a cloud advocate at Microsoft, specialized mostly in Java. So I'm actually going to show you today, I'm going to show you a workload running on ARM64 virtual machines that is actually running Kubernetes, and then we're running Cassandra on top of that. And let's get started. So everything I'm going to show you today is actually at aka.ms ARM on Azure. There it is. And you can find that and you can follow along for those of you in the recording. There is scripts here for running virtual machines and scripts here for running Kubernetes as well. So let's focus on the Kubernetes. Basically what I've done, I've already run it. The script, it takes anywhere from 15 to 30 minutes, so I'm not going to try to do that live. But basically what it does is it generates a Kubernetes cluster, and it creates a container registry. Then it downloads a Cassandra instance, which is Apache Cassandra. It's written in Java, so it's kind of an easy way to work with ARM64. And on Docker Hub, there's several platforms available, and that's why I like using Cassandra, because it covers a lot of the different platforms. And basically it downloads from Docker Hub, puts it into a container registry, and then deploys it out to AKS for us. So let's get back to how that actually works. Here's our Kubernetes cluster. Let's switch over to VS Code, and I'll show you how this actually runs. Okay, so the first thing you do, when you run this script that's on aka.ms/ARM on Azure, there are a couple of environment variables that you want to set. And then you just basically run the script, Cobalt deploy to aks.azCLI. This is a script here. It starts out by checking your Azure CLI, so you do have to have the Azure CLI installed. And then checks your subscription to make sure you're logged into Azure. And then basically sets up a resource group for you. Checks to see if the resource group exists. If the resource group doesn't exist, it creates it. And then it checks for AKS. If AKS exists, then it will continue. If you want to, you can actually create the AKS. And it's a really basic creation of AKS here. So using the resource group, you name it, you set a location, and you choose the node VM size. You choose the node count. You generate SSH keys, and that's so you can use the context when you log in. I'll show you how that works in a minute. And then you have a network plugin for Azure and a network policy for Azure, and you set up some tags, and it basically creates that. And this is the part that takes a while. It takes from anywhere from 5 to 20 minutes to actually set that up. And once that's done, you install the kubectl CLI. To do that, you use the Azure CLI, AKS install CLI. Once that's done, you get the credentials. So that's where we have up here, generate SSH keys. That actually gets the credentials and sets the credentials for you so that you have context inside of your local machine down here for connecting out securely to that Kubernetes cluster. It verifies the connection, and now we have a working Kubernetes. Basically from there, we just create a Azure Container Registry. So Docker Hub is the container registry that a lot of people are familiar with. Azure has their own private container registry called Azure Container Registry. You can create an instance of that. Here's the command for doing that, AZACR create. Resource group, my resource group, the name is my ACR name, and then location, and then set the SKU. It's just going to be standard, and then you enable admin, and that allows you to log in because you want to connect your ACR to the Kubernetes securely. So AKS update actually connects your ACR, your container registry, to your Kubernetes cluster. Basically, it's just setting up some credentials for connecting the two together. Next thing we do, we pull the Cassandra ARM64 image. There are different options here for deploying this, but I'll get to those in a sec. So first of all, what you do is you just pull the Cassandra image from the Docker Hub, and you set a tag for it, and you actually push it into your Azure Container Registry. So let's flip over to the browser here. So if I go into the container registry itself, right here, nope, that's the resource group, into the container registry. Where is it now? That's the Kubernetes service, container registry, there it is. Okay, so inside of here, if I look in repositories, you can see we have Cassandra, and we have a Cassandra v1. And basically from there, you can grab this artifact reference, and that is how you actually tell Kubernetes where to bring this in from. So we have that set up in our container registry. And once we've got that, there's a couple of different options we have for creating the actual instance. So we've got it in the container registry, it's ready to go. And then the script actually asks you for a couple of different options. You can skip the deployment right now, or you can actually deploy to directly to AKS from Docker Hub, or you can use your container registry. So if you're working on your own application, talking about migration, let's say you're building something that has been working on a x86 or another platform, and you want to run it on ARM, there's different options. So the programming language itself has to be compatible with ARM. Most programming, for example, Java, most programming languages have an option for running on ARM. Java has multi-platform capabilities, so you don't necessarily have to compile it specifically for ARM, although that is an option. But your Docker file does have to be specific for ARM. And to do that, you can actually build something. I've got a Docker file right here. This is something, and by the way, this is where AI really comes into play. If you're using AI and you're working with Docker and you're working with container images, just asking ChatGPT, or in this case, I used Visual Studio Code with the GitHub Copilot extension. I asked it, can you build me a Docker file that's going to compile this in ARM? And once that's done, it'll actually build a Docker compatible, or an ARM64 compatible Docker image that you can use and deploy to Azure. Now, the cool thing about Cassandra is they already had an image that you can use. If I show you that, let's see here, go out to Docker Hub. This is the actual Cassandra image out on Docker Hub. There's multiple different tags, but if we go down here to supported architectures, you can see AMD64, ARM32v7, ARM64v8, and a couple of others as well. And I used ARM64v8 for this particular instance. But if you have your own applications, of course, you're going to have to build them yourself. So let's go out to back to that Docker file here. And the way you actually build the Docker file, you can just say Docker build and Cassandra local. That's the README. Hold on, let me get the actual Docker file. Where is it? There it is. So the Cassandra ARM Docker file, it goes and it gets the ARM64 Cassandra latest. I've got a couple of pieces of information here. It sets the heap size for me, the new size, the Cassandra cluster name. This is all for learning local, by the way, not on Kubernetes. And then you can it'll actually create some directories for you. And it'll set up your Cassandra for local ARM64 development. And you can play around with it like that. And it exposes several ports here. The ports themselves are for, if I go down into the README here, there's actually ports for CQL and a couple other things that are specific to Cassandra. If you don't know about that, that's okay. It's a very Cassandra-specific thing. So what will happen here, when you deploy this out to Azure using that same script, okay, so back to this. So we're choosing which ARM Cassandra deployment we want to use. If we want to deploy ARM64 Cassandra directly from Docker Hub, it's going to use that image that I showed you just now. If you deploy ARM64 Cassandra from ACR, you could use that Docker file that I showed you as well. So you download it, you run it locally, and then you actually push the image up to Azure with your application built in. So that's an ARM64 Docker image that you push up to the container registry, and that'll actually deploy out to AKS for you. You do have to make several considerations for that. As I mentioned before, you have to make sure that either the programming language and or the Docker file that you've built are going to be compatible with ARM64 processors when you do. And as I mentioned, many programming languages already have ARM64 capabilities, so you might not have to do that, but you will have to have a build of your Docker image that is ARM64 compatible. It goes up to the ACR and then out to AKS. The second option we have is deploy ARM64 Cassandra from ACR, and that's the one I actually used for this demo. And you choose one or two, and if you choose to deploy this from the Docker Hub, option one, it just says kubectl apply Cassandra deployment YAML. And if I show you that deployment YAML file, Cassandra deployment YAML, here it is. So this just deploys Cassandra, very simple. You mentioned the architecture, ARM64, and it uses, in this case, I've got the DataStax version of this, which needs a password, by the way. But if you use the ARM64 version of the Apache Cassandra instance, that's an option as well. That's the one I use for deploying out to the ACR. The DataStax one, DataStax is sort of a corporate custodian of Apache Cassandra. So they have their own customized version of this with configurations here, the CPU. So you can see from the Docker file and the YAML file, very similar capabilities here. So they've got the CPU, you've got the memory specifications, the limits. This is a very small instance of Kubernetes, so we're doing it that way. And then those container ports that I showed you before in the Docker file are similar here as well. It opens those up for intranode, TLS intranode, JMX, and CQL. CQL is sort of like the query language for Cassandra that you use for that. Then you have a mount path, which is Cassandra, the base. and that's how it actually knows to run Cassandra. So this actually gets deployed, and then there's a service that gets deployed as well. So the service is just a way to run a deployment application. If you're going to be scaling, you use the service to do that, but if you're just doing a deployment, you use the deployment. All right, so back to the script for you. So the next thing we do, we're actually going to do something a little bit different for deploying from ACR. And for that, we actually need to build a new file for deployment. And the reason why is because we have a new ACR that we've generated as part of this script. So you actually have to have the image name to find it, ACR name, and then the ACR image and the ACR tag. So if we go back to the container registry, that's what this is here. So you see the repository here in our ACR, Cassandra, and V1 is the V1 that we're using for this. So it actually builds that for you dynamically as part of the script because you don't have that ACR that exists before the script starts. If you're downloading from Docker Hub, that's a static image, and it's always there so you know where to find it. But when you're building this, the way to do that is you say cat, which is a bash command for Cassandra deployment from ACR YAML, and it generates this YAML file for you and tells you it's a deployment. Once again, all the settings that you need and the ports that you need open. Okay, from there, we just do a kubectl apply, and it's actually going to deploy that out to Azure, and then kubectl apply Cassandra service, and that deploys the Azure and the service. Now the service we don't have to update because it's already pre-built. There's no need to pull it from the ACR, so we don't have to dynamically create that for us. Let's see. Then we validate the deployment. We do a kubectl get pods, and we can do that here. Let's do that here live. Here we are. So kubectl get pods, and you can see Cassandra's running. It's running locally, and you can see as well the deployments themselves are here as well. So you've got Cassandra, core DNS connectivity, and everything's running there. You can also see this in the portal, and you can deploy this from the portal. Here's the actual Kubernetes. As I mentioned before, this is the resource group with the Kubernetes deployment and the container. Inside of the Kubernetes service, if we drill down into that, there's one way to connect. So if you're in Kubernetes service here, down here you can download the cluster credentials. So AKS get credentials. I can copy that in so I can set my credentials to connect from my local machine up. But once I've done that, I can go back and I can look at the different services and ingresses in the portal. And I can also drill down into any specific service and see the different ports that we're working with as well. So as I mentioned before, CQL is the query language, intranode, TLS intranode, and the JMX. So you saw those in the Docker file and in the Kubernetes deployment, and here they are in action running. You can also see the YAML. This is some YAML you can use for later to copy and rerun this. My YAML is really simple. This one is way more specific about what actually works and what actually runs, but you can actually copy this and reuse it later. And or, one of the things I like to do is take this YAML and then copy it to GitHub Copilot inside of VS Code and ask it to generate a new instance for this. And it'll actually give you some cool customized platform-specific settings that you might not have thought of for security and other things inside of, based on this and inside of your Azure deployment as well. So that's kind of cool. All right, and that's the container with the image. Do we have, how much time do you need for the, you just need 5 minutes? Okay, so we have an extra 10 minutes. I'm gonna show you how to do this from the portal as well, because I think that's important too. So I showed you how to do it with the CLI, and once again, you can find that at aka.ms/arm on Azure. But let's go into the portal and I'll show you how to do that as well. So if I go in here, and I create, let's see, Kubernetes service. So portal.azure.com. You can actually create a new one. Kubernetes cluster. Now, what we want to do actually is we want to just say, that's going to create a new Kubernetes cluster inside of this. So, yeah. Let's credit this. Yeah, there we go. So we're going to create this new one. We're going to use the same resource group we have, which is bbens. What happened? Okay. Okay, it's not finding it. Let's create a new one. bns live K8s. So let's create that. All right, and we have to have, let's use standard production, and let's call the Kubernetes bbens live K8s, and let's do that here. Okay, we're using Canada Central. That's important. So not every location inside of Azure, not every Azure region has ARM64 capabilities. So you do have to figure that out. And I do, if you go to ms/arm on Azure, let me go back there quick. I have a script for you for that. Generated this pretty cool script, which is check ARM64 quota. There's a shell script and a Terraform version of this. And basically, it goes through every region that currently has ARM64 capabilities, checks to see if there's any available resources, and checks for your subscription quota as well, because there is a quota, for example, at Microsoft, the quota is very limited because customers come first, so we don't have location access for every ARM64 instance. But here's all the regions that have it right now. If you're watching this on a recording, there might be more added later, and eventually they'll be in every region, but for now they're limited to some of the regions. And the next thing you do is it just basically cycles through these and gives you a nice table that tells you if you have availability and how many are available in each region and how many are available in your subscription quota as well. So that's kind of cool. Check that out at aka ms/arm on Azure. So back to the portal quick. All right, so I'm using Canada Central because I know I have 16 ARM instances that I can use over there. And the first thing we're going to do is skip over that. Everything's okay. I have to turn off the zones because that requires multiple regions, and I only have instances in Canada Central available. So then Kubernetes version, everything could be kept default. And then what we want to do is we want to set the user pool. Now this is a little bit counterintuitive, but basically what you do is you go into node size here, make sure it's on Linux, node size, choose a size, and this is where you actually do your DPLS, I believe it is. Which one is it? Hold on, let me get the code for that. It's up here in the script that I have. I wasn't planning on doing this part, so there it is. Standard DP4S v5. Okay, so DP4S. Oh no. What would it be? DLP? What would be the code for that? D4P? Thank you. D series, there we go. So we're going to do the smallest one here. We'll select that. And that basically gives us the option for using, for our user pool, the ARM64. And the agent pool can still be x86. You can use both. You can have both of these agent pool and user pools as ARM, or you can have a mixed environment. It's totally okay to do that. Then we'll leave the rest default. We'll go to there is one thing I have to do here. I have to create an Azure registry. That's in the next screen. Yeah, container registry, create new. Let's call this one bbens. You can't have a dash in the name. But that'll work. Okay. All right, and we do want to enable, yeah, so next, we can just leave everything else default. We review and create, and basically we can create something from there. Takes the validation for a second. So this will do exactly what I did in the script. It'll create the AKS, it'll create the registry, it'll connect the two together, and allow me to just use this, but I'm using the portal instead of the CLI. So if you're not comfortable or familiar with the CLI, it's going to give me a quota issue. I know what it is. It's a quota issue, but yeah. Insufficient regional quota for my, you probably won't get this. It's because I'm Microsoft and customers come first, so it won't build quota for me. But anyway, I think I'm going to pass it over to Bhumik now. This is how you actually, so I showed you how to build it with the CLI and with the portal as well. And go to aka.ms/arm on Azure for the scripts. They're all there, and you can just run them. So I'll pass it over to Bhumik.
Thank you, Brian. Appreciate it. We have more demos at the booth as well if you want to spend more time. Some of us will be at the booth afterwards. I'm going to wrap it up and have a couple of minutes for questions as well, and we can stay outside for more questions. I mean, as you saw, there's a variety of workloads being deployed on ARM platform and Cobalt 100. One of the initiatives we've recently made available for everyone to take advantage of the ARM-based migrations are what we call ARM Cloud Migration, right? So there are resources out there for you to leverage. So I'm going to quickly walk through them, right? I mentioned the dashboard earlier. This is where you can just quickly go and check if your software that you are deploying is enabled on ARM and where you can go get the bits. And then we have what we call learning paths. These are how-to guides. We have 100+ of them where you can specifically just basically follow instructions to deploy your applications, right? A lot of them also have performance optimization tuning, best practices across the board, right, for you to leverage. We also have developer initiatives, right, including our developer program. There are developer ambassadors, including from the Microsoft ecosystem. We do workshops and code alongs that you can find on our website that you can leverage some of the resources. And these are hands-on, right? So these are hands-on workshops, virtual, in-person resources for you to leverage. And then last but not least, you can even engage directly with our experts, right? So if you go to the arm.com/migrate URL, there's means for you to, whether you want to open an issue on GitHub, if you're having some issues, you can do that, or you can just fill out a form and reach out to ARM. And in a lot of cases, we can work directly with Microsoft engineering, and this is us sharing best practices and deployment guidance for you to migrate, right? So, feel free to take advantage of that. I think with that, we'll wrap it up here. Thank you for your time, both in the room and online, and thanks for all the speakers sharing all their journey to migrating to ARM stories, and we can take some questions. Thank you. There's a mic there if there's a question, and I think we can take maybe one or two if there is any. No questions is fine as well. We don't have any seeded questions, so thank you, everyone.